At this moment, I will be discussing about the Laboratory Activity 12, the multimedia processing. So the objectives are to perform basic audio and image processing using Python, to understand concepts like filtering, transformation, compression basics, and noise removal in audio and images. So here's the code for this. I've loaded this sample trumpet audio file provided by the Librusa. So the Y contains the audio samples, while the SR is the sampling rate. And also here I've plotted the audio waveform to visualize the audio signal in the time domain. So the waveform shows time on x-axis and also labeled in y-axis. Next is the spectrogram, the frequency domain analysis. So I've computed the short time Fourier transform. So the spectrogram shows the time versus frequency. So this is very useful, that represents the signal magnitude in decibels. Next is that I've designed a low-pass filter. So this function implements a Butterworth low-pass filter. So it allows low-frequency components to pass and attenuates high-frequency noise. So the cutoff frequency is set to 100 Hz. So also a filter has been applied. Is that compare the original and the filtered audio signals. So we plot the 2000 samples of both the signals. So here, this is the comparison. The filter signal is, later on we're gonna see that the filter signal will be much smoother while the high frequency is reduced. High frequency noise is reduced. Now, to save the audio files, we need both the original and the filtered audio that are saved here as the WAV or that WAV files. And next is that the image processing section. This is very optional, but in OpenCV is available. So the program proceeds with image processing. Tries to load the Lena image, a common test image. So if unavailable, a random grayscale image is used. So next is the 90 Fourier transform of the image. And finally, we've come to the image low pass filtering. So here, the Gaussian blur acts as a low pass filter. So it reduces sharp edges and many more. So next is the image noise and denoising. Here I've plotted all the codes. So now let's see how this has been presented using this. Let's start debugging. So as you can see, here's the audio waveform. Here's the spectrogram in decibels. The original versus the low pass filtered audio signal. So this has been compared. And next, as you can see, here's the original image. But now, here's the magnitude spectrum. And okay, here's the original image and the blurred image. So it undergoes the low pass filter. So here's the original noisy image and the noise image, the mid-channel filter. So that's all for this video. Thank you.